Hello students, today we are going to discuss about the topic energy meters. It is a syllabus topic present in your 5th unit, electrical measurement. The contents of this presentation includes what is an energy meter, why it is used, what are the parts used in an energy meter, and finally, what is the basic working principle of the energy meter? Come, let's move on to the topic. Energy meter, we are all familiar with the term. It is actually a meter which is used for measuring the energy utilized by the electric load. So, energy meters are widely used in domestic areas for the measurement of electric power consumed by the customers. And also, these energy meters are commonly used in industrial sector for controlling the electric power of various machinery according to its reading and for measurement of electric power. So, energy meter is nothing but a meter for measuring the utilized energy. So, what is energy? Energy is nothing but the total power consumed and utilized by the load at a particular interval of time. So, you can see from the figure, this is the basic construction diagram of an energy meter. This is an induction type energy meter. The energy meter has 4 main parts. They are driving system, moving system, braking system, and registering system. The driving system, as you can see from the figure, comprises of electromagnets. It is the temporary magnets which is excited by the current flow through their coil. The core of the electromagnet is made up of silicon steel laminations. The driving system actually involves 2 electromagnets. You can see from the figure, the upper one is called the shunt electromagnet and the lower one is called the series electromagnet. The series electromagnet is excited by the load current flow through the current coil. The coil of the shunt electromagnet is directly connected with the supply and hence carry the current proportional to the shunt voltage. This coil is also called as the pressure coil. The center limb of the magnet has a copper band. These bands are actually adjustable. The main function of this copper band is to align the flux produced by the shunt magnet in such a way that it is exactly perpendicular to the supply voltage. The second system is the moving system. The moving system is nothing but the aluminum disc that is being mounted on the shaft of the alloy. The disc is placed in the air gap of the 2 electromagnets. The eddy current is induced in the disc because of the change of the magnetic field. This eddy current is cut by the magnetic flux. The interaction of the flux and the disc induces the deflecting torque. When the devices consume power, the aluminum disc starts rotating, and after some number of rotations, the disc displays the unit used by the load. The number of rotations of the disc is counted at particular interval of time. The disc measures the power consumption in kilowatt hours. The third system is the braking system. The braking system has an important part as the permanent magnet. The permanent magnet is used for reducing the rotation of the aluminum disc. The aluminum disc induces the eddy current because of the rotation. The eddy current cuts the magnetic flux of the permanent magnet and hence produces the braking torque. This braking torque opposes the movement of the disc, thus reduces their speed. The permanent magnet is adjustable, due to which the braking torque can also be adjusted by shifting the magnet to the other radial position. The final and fourth system is the registering system. The main function of the registration or counting mechanism is to record the number of rotations of the aluminum disc. The rotation is directly proportional to the energy consumed by the load in the kilowatt hour. The rotation of the disc is transmitted to the pointers of the different dial for recording the different readings. The reading in kilowatt hour is obtained by multiplying the number of rotations of the disc with the meter constant. Come now, let's move on to the working principle of an energy meter. The energy meter has an aluminum disc whose rotation determines the power consumption of the load. The disc is placed between the air gap of the series and shunt electromagnet. The shunt magnet has the pressure coil and the series magnet has the current coil. The pressure coil creates the magnetic field because of the supply voltage, and the current coil produces it because of the current. The field induced by the voltage coil is lagging by 90 degrees on the magnetic field of the current coil, because of which eddy current is induced in the disc. The interaction of the eddy current and the magnetic field causes torque, which exerts a force on the disc. Thus, the disc starts rotating. The force on the disc is actually proportional to the current and voltage of the coil. The permanent magnet controls the rotation. The permanent magnet opposes the movement of the disc and equalizes it on the power consumption. The cyclometer helps in counting the rotation of the disc. So this is the basic principle involved in the work